Okay, 4.2 isosceles and equilateral triangles. This is a review of those triangles, and then I'm going to throw some theorems that you can use. So an isosceles triangle is a triangle that has two sides that are what? Equal. They're the same. Yes? So we're going to learn some more things about that other than just the two sides are congruent. So the isosceles triangle theorem states if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So if we look at my picture, can I tell this is an isosceles triangle from my picture?
Yeah.
How?
Because the lines.
Because the two lines tell me that this is an isosceles triangle. And so if this theorem tells me if I have two sides that are congruent, the angles opposite those sides are also what? Congruent. So these two angles are congruent. These are known as a base angle. And this is known as the vertex angle. Now, can I turn this triangle upside down? Yes. And the base angles are still the angles that are the same. Okay? Kind of makes sense, doesn't it?
Yeah.
Okay. What do we know that all the angles in a triangle equal? 180. So if I knew my vertex angle, could I find A and C really easily?
Yeah.
Subtract from 180 and divide by 2. So all of the information we know about triangles is going to come back into play also. Okay. So now the converse, remember converse means we just flip it up, right? We switch it. So the converse says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if I'm told the sides are congruent, the angles are congruent. I've told the angles are congruent, then what's congruent?
The sides.
The sides. Just undoes itself.
It's like
So
adding and
they've said these A and B or A and C are congruent. So what do I know are also congruent? A, B, and B, C. Does it tell me anything about the side opposite B? No. Tells me nothing about that, does it? It just tells me that A, B, and B, C are congruent. Okay? So it's like a big puzzle. This just says find the value of X. Could it also say find the angles? Yes? Okay. So I have the triangle over there. I have 28 and then 5X plus 9. It says find the value of X. So what do we know about that picture?
That the vertex is the 20. So the other angle would
Yep.
be also 20.
We know this angle is 28 because my isosceles triangle theorem tells me the angles opposite the two sides are congruent, right? And when you guys think opposite, take an arrow and point. Does this make sense?
Yeah.
Like point right to those. Okay?
So 28 plus 28 plus 5x plus 9 equals 180.
Yep, because all the angles. Now, have we solved triangles like this before?
Yeah.
Yeah. So 28, I bet is 56. And plus 9 would make it 65.
Yeah.
So minus 65. So 115
Yeah.
equals 5x.
23.
And then divide by 5. And I agree with 23. You guys agree with 23? Okay, so 23 is not the measure of the vertex angle, is it? It's just x. Now, I will have people normally, they won't pay attention, and they'll say 180 minus 56, 4, 124, and they'll stop. Did that answer what did I ask it? No. What is 124?
An angle?
124 is the vertex angle, yes? But is that what I asked for? No. Okay, so make sure we're doing what we asked for. Okay, so negative 4x plus 9 and 8x minus 3. Yeah, because I know that those angles are congruent, right?
Yeah.
So negative 4x plus 9 equals 8x minus 3. So I'm going to add 4x and add 3. How about you guys?
Yes.
So 12 equals 12x. So I'm pretty sure that means x is 1.
Oh, we have fractions.
Oh no. Oh well. Okay. So now I'm not talking about angles. I'm talking about
No, that's not fractions. That's dividing.
sides, the converse, right?
They're different.
So what do I know about?
So x plus 20 and 8x over 3 are equal.
Yeah, they are congruent, right? Because they're opposite. Does everyone, when I say opposite, I want to make sure everyone understands the opposite is these two. Yes? So x plus 20 equals 8x over 3. Okay? So how do I need to deal with that?
Convert the 20 to a fraction? Or
Mm-mm. Don't have
Can we
to.
make it a mixed number?
Hmm? No.
Subtract 20.
No.
We add the
Times everything by 3. If you don't like fractions, learn how to get rid of them, guys. If I multiply every single thing in there by 3, is that going to is that going to move the 3 from the denominator to the numerator? Yeah. I'm going to multiply this side by 3 and this side by 3. So I have to make sure I distribute. So get 3x plus 60 equals, no, 8x. Because the 3 is reduced, right? That was the whole point. So now, do I have a very basic problem?
yes.
Yes. If you don't like fractions, learn how to get rid of them. So minus 3x.
So what do we do after we have the x then?
Well, it just says find x.
Oh, so we don't need the 6x minus 12?
Well, we could. So x equals what? 12. So if it wanted the values, I'd just plug in what? X. So 8 times 12 over 3. Well, 3 goes into 12, right? 4 times. So 4 times 8 is
32.
32. Well, if I plug 12 in here, 12 plus 20 is 32.
Do we have to do that? Or can we
You have to answer whatever it asks you. I would do it to both. Just set it right there. I would do it to both to check. Because you're right, these better be the same, yes? But what if you messed up? Right? And then 12 times 6 is what?
12 times 6?
Isn't that 72?
Yeah.
72 minus 12 is 60. There's no rule that is going to tell me this base isn't, that PQ. There's nothing that's going to tell me that because it's not an angle. I'd have to plug it in. So just watch what it says. These say find x, but could it say find all the sides? Yes. Okay. So what are we going to do with this one?
Congruent. Add them all to equal 84.
Okay. We're not talking about angles.
Never mind.
We're talking about sides, right?
Yeah.
Okay. So this side and this side are
Same.
congruent. So is that 2x plus 11 just extra information? Yep. So what, minus 4x plus 1? So 4x equals 6.
This is so much easier than the Pythagorean theorem.
Pythagorean theorem is easy too. Is 3 over 2. Do not ever tell me 6 over 4, right? Now, guys, if I had to plug it in, would this be hard to plug in?
No.
No, because everything with an x is divisible by 2, isn't it? So as long as you divide by 2 and then multiply, it makes it pretty easy. Okay, but that's not what it's asking. Questions on that? Okay. Isosceles triangle angle bisector theorem. Okay, isosceles triangle is what? What is it?
Two angles that are congruent.
No, what is an isosceles triangle?
Two angles are
Sides are the same.
Two sides are the same. That's the theorem. That's the angle theorem. I'm just
I'll
asking.
just read it off.
Okay, I get what you're doing. I was just asking general knowledge. Okay, isosceles triangle is a triangle with two sides the same length, yes? Okay, what is an angle bisector from chapter 1?
Isn't that something
Oh, you
that
split it
crosses?
in half. You split it in half.
Never mind.
It bisects it. It cuts it in exactly in half. Okay? So we have something with an isosceles triangle and an angle being bisected. Cut in half. Okay, so that's what this is about. So, let's go through it. It says, if a line or line segment bisects the vertex angle of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. Okay, so what does perpendicular mean?
It's like opposite.
The same.
Or curve.
Meets at what?
The center.
A 90-degree angle. Okay, so it said if a segment bisects the vertex angle, which angle's the vertex?
The top.
The top one that doesn't have any one that's the same, right? Then it crosses it meets the next side at the perpendicular bisector. Okay, so look at your first picture.
So that's the right angle.
So this angle is bisected. How do I know this angle is bisected?
There's a line right
And there's
No.
two different- There's two little.
The arcs, not the line, the arcs, right? Okay, so the angle is bisected. So it tells me when it meets the side of the triangle, it meets at a right angle.
So
So in this picture, and it's the perpendicular, so perpendicular is the right angle, bisector, which means it does what? Cuts it in
that's it.
two equal pieces, right? So do you see this picture then? Okay, so this angle is congruent to this angle. If that is true, then I have a right angle down here. So I've made one isosceles triangle into two right triangles, haven't I? And if I needed to use the Pythagorean theorem on part of it, could I?
Yeah.
Yeah, that might come up. Do I know that AD is congruent to DC?
Yeah.
Okay, so there's things I know about this triangle now. Okay, so I need to know PR and the measure of RSQ.
So would R be 31 degrees?
Yes, R would be 31 degrees because that's another base angle.
So then we do 180 minus 62. Or, yeah.
But that wouldn't give me RSQ because RSQ is only how much of that angle?
Half.
Half of it.
So
it's
it's
divided by
divided by 2.
Right. So the measure of angle RSQ is equal to 1/2 the measure of angle S, correct? If S is the whole thing. So you said 180 equals 31 plus 31 plus, can I just put angle S?
Yeah.
Okay. So this is 62. So minus 62. So 118. So the measure of angle S is 118. So now I need to take half of it, which gives me, what, 59 degrees?
Yeah.
Okay, now, could I also just look at this triangle right here?
Yeah.
Could I?
Yeah.
Because I know that this is 90, right? And I know that this is 31.
Yeah.
So could I take 180 equals 90 plus 31 plus the measure of angle RSQ?
What?
Doesn't 90
Yeah.
plus 31,
31.
and this is RSQ, doesn't that equal 180?
Yeah.
Yeah.
So this is 121,
Yeah.
so minus 121,
Oh,
which is
59.
59 degrees.
So 50. Oh, okay.
So could I do this either way?
Yeah.
Yeah. Josh? Could I do this either way?
Yeah.
Okay. Don't lay back on my chair. Okay, an equilateral triangle. What does equal mean?
All the same.
All the same. What are laterals?
9. 3.
You're of a triangle. There are angles and sides. Yes. The laterals are the sides. Okay. So an equilateral triangle is equal angular. What does that mean?
All the angles are equal.
All the angles are equal. So an equilateral triangle is an equal angular triangle. And equal angular triangle is an equilateral triangle. Oops, that should not be an N. Okay, so an equilateral triangle is an equal angular triangle, and an equal angular triangle is an equal lateral triangle. So that means the sides are equal and the angles are equal. Sides can be all different lengths, but if I'm telling you I have a triangle and all of the angles are the same, what are every single angle in every single equal angular triangle ever?
They're all gonna be the same.
And what is that number?
What's 180 divided by 3?
Oh.
I can't do the math, but I know.
What's 18 divided by 3?
18?
6.
60. Yeah.
So 60 degrees. Every equilateral triangle, the angles are what? 60. Every single one of them.
Hold on.
Because 180 divided by 3 is what?
60.
60. Yes.
Yeah, Jacob.
Those two, like the first word and the second word, the exact same thing.
What?
Yes.
Okay.
Okay, it's saying an equilateral triangle is an equal angular triangle, and an equal angular triangle is an equal lateral triangle. If I tell you all the angles are congruent, that means all the what? Sides are congruent. If I tell you all the sides are congruent, then all the angles are congruent. And all the angles every single time are what?
Congruent.
Are what? 60. Every single time, because there's only 180 degrees in any triangle, correct? And if there's 3 angles that are all the same, they all have to be what? 60. Okay, so I have a picture. I have an equilateral triangle and I have a isosceles triangle in that one picture. Do you see them? equilateral, isosceles.
So do we label
And
all
it
the-
says angle CBD.
Is 130.
So CBD. So that means this whole thing right here is what? 130. This whole thing is 130 degrees. It wants to know B80. So B80, it wants to know this one. How can I figure that out?
Divide it.
So you put 60 on the.
Well, it'll be 60 minus.
Jacob.
Sorry.
You do what, Jacob?
Okay, since ACB is an equilateral triangle, just put the 60 to one side, and then subtract 180 from 130 or whatever.
How about 60 from 130?
Yeah.
Okay. So he's saying 60 is over here and the whole thing's 130. So 60 minus 30 is 70. Okay. So you got more of a plan, Jacob?
That was it.
Okay, that was it.
Can I go?
Okay. You want to pass it to him?
Yep.
Okay. Dayton?
Okay, so now we do 180 minus 70.
Okay. Why?
So then we get 110, and we divide it by 2, and that's the other two.
Because these two angles are going to be congruent, right? Okay. So divided by 2, which is 55. So the measure of angle B80 is 55 degrees. Okay? So I want you guys to think about this one while I hand out your worksheet. What?
Can I also have the worksheet you graded today?
Yes.
What does it want from us on the second one? Does it give us any directions?
Okay, find all the angles.
Oh.
Sorry. I know, it doesn't give you any directions, so I just said the directions for find everything.
That one's hard.
No, it's
I will have to get started first. Oh wait, we're stupid.
Contain yourself, Josh.
Can we not use calculators in here at all?
We will sometimes.
Yeah, we were doing like, what are they called?
Oh, our trig functions, SOHCAHTOA.
Yeah.
Okay, does anyone got me a starting point?
I got one.
Lily.
So you take the 72 and you divide, or not divide, you subtract that from 180 to get the, what angles T and B equal. But you have to
Like
take
the
that-
sum of them?
The sum of them, yeah.
Okay, so 108.
Yeah.
Okay, and then divide it by
2.
2, so that gives me 54 and 54.
Yeah.
Okay,
And
who do you want to pass it off to?
I got it all done.
Anybody else besides Tate want to?
I'm gone.
What do those two equal? Tiana, what do those two equal? It's a straight angle. What is the equal, guys? 180. So if I have 54, how would I find that other side of it?
You subtract.
You subtract
So-
from 180.
180 minus 54 is 126. So this is 126. Anyone want to jump in other than Tayton or Lily? Aslan?
Well, then after you got that, you gotta divide it by 2. So you get
I got to do something first. You're close. Jacob would like to help you out if you're willing.
I'm willing.
Okay, Jacob, what does she got to do first?
So subtract 126 by 180, right?
Uh-huh.
And then divide it by 2?
Yes. You guys have, because this is going to be 180 minus 126, which is 54 because we already had it right here. And then we got to divide it by 2. See that, Aslan, now?
Yes.
Okay. So what do we get? 27?
28.
27?
20. Oh, I did my math wrong.
Wait, hold on, but still
But
why?
I got it right.
Okay, so
Don't
I did my
every
math wrong,
triangle
but I got it
equal
right.
180?
yeah, so we had to take 180 minus 126.
Oh, just kidding. I think I get it.
Yeah, you just forgot that you had to subtract before you divided by 2.
Because that'd equal a lot more.
Yeah. Yeah, it would. Okay, so on your worksheet, you've got lots of triangles. Do you see vertical angles on there? Yes, we got to remember our vertical angle rules. The pictures may look a little different, but you're going to find isosceles triangles and what? Equilateral triangles?
Lateral.
Okay, so different program makes different pictures. But that's all you got. You got a lot of space to work. It looks like a lot of problems, but there aren't really that many. A lot of space.
So just what we've been doing?
Yep.
Like what we just did.
What we just did, yep.
Okay.
So you got to